In section 1.5 of chapter 1, we'll look at ways to set up our experiment. We'll look at how to identify what type of a study it is. Is it an observational type of study, or are we going to be doing an experiment? And we'll also look at different types of samples and ways to collect samples, and how to classify that. So let's get started. When we design our study, we have two different types. We have observations and experiments. And so on your test, you'll need to be able to identify which one was used in a particular situation. In an observational study, we observe and we measure, but we make no attempt to modify. So we're not changing the subjects or the outcome in any way when it's an observational study. Now there's three different types of observational studies. There's cross-sectional, and when it's a cross-sectional, data is collected at a certain point in time, at one point in time. Retrospective is from the past. So data is collected from the past using records or interviews or so on. And then prospective is from the future. So how do we get data from the future? Well, in a prospective observational study, what we do is we follow a group along the future. So it could be a 10-year study or 5-year study. And these groups are generally called cohorts, and we collect data from them at certain points in time. So that's the difference between prospective and retrospective and cross-sectional. Now an experiment's pretty obvious. In an experiment, we apply some type of a treatment to modify the subjects or the outcomes. And so when we set up an experimental design, we want to try to control the effects of the variables. And there's something called the placebo effect. The placebo effect is where somebody thinks that they are getting better because they know that they're taking the medication or they're taking the drug that's being researched instead of just a placebo, and vice versa. So what we want to do is control that effect where somebody physically feels like they're getting better because they think they're taking medicine. So what we do is we do something called blinding. Blinding is where that person doesn't know if they're getting the treatment or not. So you won't have that psychological effect taking place. A double-blind experiment is really good because in that scenario, neither the patient nor the observer knows if the patient is actually getting the treatment or not. And so they do that just by setting it up with maybe labeling the participants in certain ways and labeling the drugs in certain ways so that the researcher doesn't know at the time. We also want to control variables, control effects on the experiment by putting subjects into similar groups or blocks. And then another term that you might come upon is confounding. Confounding occurs if you're just confused and you can't really tell if there was an outside variable that affected the outcome or not. Now an experiment is something that we should be able to replicate the results over and over again in similar studies. And then we also want to make sure that when we set up our experiment that we choose our sample very well. On page 34, let's look at a couple of examples where we determine whether the study is an observational study or an experiment. A Gallup poll surveyed 1,018 adults by telephone, and 22% of them reported that they smoked cigarettes within the past week. So is this an observation or an experiment? Well, we need to ask ourselves, is there a treatment being applied or not, or are they just simply measuring results and taking down information? And this is just a poll, so this would be an observational study. No treatment was applied to the subjects, we're just recording information. A study of the effectiveness of echinacea involved 707 cases of upper respiratory tract infections. Children with 337 of the infections were given echinacea, and the children with 370 of the infections were given placebos. So this is a good example of an experiment. Usually experiments are very obvious because you can see they're giving some type of a treatment, and we're measuring the effects of that treatment on the subjects. Here we want to identify the type of observational study, and recall that there are three types. It can be cross-sectional, which is data collected at one single point in time, or it could be retrospective from the past or prospective from the future. A researcher from Johns Hopkins University obtains data about the effects of alcohol on driving by examining car crash reports from the past 5 years. So since this person is collecting data from the past, this is an example of a retrospective observational study. Physicians at Mount Sinai Medical Center plan to study emergency personnel who worked at the site of the terrorist attacks in New York City on 9/11. They plan to study these workers from now until several years into the future. So since we're actually following these workers into the future and obtaining data from them later, that would be a prospective study. Now we're going to look at types of samples. And so when we decide if we're going to do a research experiment or an observational study and we have to get a group of people to participate, well, there's different ways to get that sample. So we can do a random sample, and in a random sample, each individual has an equal chance of being selected. So a really good example of a random sample is where you just put everybody's name in a hat and you randomly draw names out of the hat, so everybody has equal chances of getting selected. Or if you somehow use a computer to generate your sample and it's randomly selected. Now an offshoot of a random sample is a simple random sample. And in this, every sample, and this usually involves a group, so we're selecting groups, and every possible sample of a size has an equal chance of getting selected. So we'll talk about that in some later examples. Another type of a sample is a systematic. So we can systematically pick our test subjects. And so when we do this, like we say, we're going to pick every 10th person in the room, or we're going to pick every 5th aspirin off the supply line and test it for quality. So when it says the phrase every 5th or every 1st or every 10th, that is a systematic approach. So look for that key phrase. Another type of sample is convenience. When we choose subjects that are easily available to us, for instance, we survey people who live with us, that's convenience. Or we survey people at our work, that's a convenience sample. And then there's stratified. When we do a stratified sample, what we're doing is we're grouping the population into subgroups. And then we take a sample from each subgroup. So for instance, let's say that we group everybody by zip code. And then we take 10 random people out of each zip code for our sample. That's an example of a stratified sample. We're grouping and then taking a sample from each group. Another type of grouping sample is a cluster. With a cluster, we divide the population into groups. We randomly select some of the groups, but then we actually sample all the members of those clusters or groups. So here's a comparison between stratified and cluster. I said with stratified, we can group them by zip code, and then maybe we take 10 people randomly from each zip code for our sample. So that's stratified. It's a sample from the group. Whereas with cluster, let's divide everybody from the population into their zip codes. But then what I'm going to do is I'm going to randomly select some of the zip codes. So I might select everybody from 65807 and everybody from 65804, and I choose all of the members of that zip code for my sample. So that's the main difference between stratified and cluster. Stratified is a sample from the groups. Cluster, it's all the members from the group are being surveyed. So let's practice identifying which types of sampling are used. Is it random, systematic, convenience, stratified, or cluster? And this is problem 10 on page 35. A study of the effectiveness of echinacea involved upper respiratory tract infections. One group of infections was treated with echinacea and another group was treated with placebos. The two groups were determined by a process of random assignment. So I'm going to pick out the word random here. This doesn't always mean it's random, but generally if they use that word, that is the type of sampling that's used. So it says the groups are determined by a process of random assignment. So they're really not giving us any other hints other than that's what it is. Problem 12 says the author was an observer at a sobriety checkpoint at which every fifth driver was stopped and interviewed. Well, I hope you picked up on the phrase every fifth driver. Whenever we see that phrase, that's a systematic approach to selecting our sample. Question 14 says the U.S. Department of Corrections collects data about returning prisoners by randomly selecting 5 federal prisons and then surveying all of the prisoners in each of the prisons. So if we pay attention to this, this is a grouping approach. We're grouping it by prisons, and then we're randomly selecting 5 prisons and surveying all of the people in them. So that is a cluster approach because we're grouping and then we're choosing all. Question 16 says the author surveyed all of his students to obtain sample data consisting of the number of credit cards students possess. So this to me sounds like convenience because he's surveying all of his students. In question 18, in a study of college programs, 820 students are randomly selected from those majoring in communications. 1,463 students are randomly selected from those majoring in business, and 760 students are randomly selected from those majoring in history. So this is grouping. We can see that we're grouping students by their major or by their college. And then are we selecting everybody in those particular colleges, or are we only selecting part of the people in those colleges? And we can see that we're selecting samples. And so stratified goes with samples. We're grouping and then choosing a sample from each group. And in question 20, in a Gallup poll, 1,003 adults were called after their telephone numbers were randomly generated by a computer, and 20% of them said that they get news on the internet every day. So our sample was grouped by telephone numbers, and those telephone numbers were randomly generated from the computer. And so that's an example of a random sampling method. And in question 22, a quality control engineer selects every 10,000th M&M plain candy that is produced. Does this sampling result in a random sample? Well, the phrase every 10,000th is a systematic approach. So this is a systematic sample, but is it random? Well, if it's random, every single M&M candy should have an equal chance of getting selected. And it actually doesn't, because if we're already selecting the every 10,000th, then the first one doesn't have a chance of getting selected, the second doesn't have a chance. So therefore it's not a random sample. Is it a simple random sample? Well, no, because in a simple random sample, every individual has to have equal chance of getting selected as well. In order to test for a gender gap in the way that citizens view the current president, the Tompkins Company polls exactly 500 men and 500 women randomly selected from adults in the United States. Assume that the numbers of adult men and women are the same. Does this sampling result in a random sample? Well, all that it tells us is that it does indicate that these people were randomly selected. So we don't really know if it was a particular approach like systematic or something like that, but we know it's random because it tells us. So yes, it's random. But is it a simple random sample? Well, to compare the two, in order for it to be a simple random sample, notice that our survey includes 1,000 people total. We have 500 men and 500 women. Well, in order for it to be a simple random sample, we should be able to get any group of 1,000 people that we want. Any group has an equal chance of getting selected, meaning that we could get 600 men and 400 women and still come up with 1,000 participants. However, because of this approach saying that we select exactly 500 men and exactly 500 women and that those numbers have to be the same, then what we're doing is we are not allowing ourselves to have any chance of 600 and 400 because they're saying that it has to be equal. So therefore it's not a simple random sample.